5.2, let's start with the sigma notation. And then we're gonna cover how to find the area. Sigma notation. The sum of n terms. You have n terms, like from 1 to 100. The sum of these terms written as, you see this sign? This is the sigma, we're gonna call it summation. Summation, that means the sum of n terms start from I equal 1 to the n. So from I equal 1 to 50, from I equal 1 to 60, 2 million. This is the sum. Going to be the first term plus the second term and keep going. So I is the index, K and T is the same thing, like this means the boundary starts from the first number to the 100, the number of terms. This sign is called summation. So you have summation from I to n, the term AI. N is the bounds until when is going to end. So sometimes the index, sometimes they're going to tell you from K equal 1 to n, from T equal 1 to n, from I equal 1 to n. So it's the same thing. You're going to find K, T, I, the same thing. Don't get confused. N is the bounds. That means it's going to from this number to this number. And here is the summation formulas. We're going to use this a lot. So you have to at least memorize these numbers. Of course, you're going to use the notes, but I prefer that you can memorize these rules. Summation to any number, to a constant, that means the same number from 1 to n. And instead of using the summation, it's going to be just the number times n. For example, if you want to find summation from I equal 1 to 5, to any number, to the 2, that means is going to be the number how many from 1, 2, 3, 4, and 5. You're gonna add the number, the same number 5 times. So instead of doing that, you're gonna say, okay, I'm gonna use this one, which is the number is 2 times n is 5. So it's going to be 10. That means 2 plus 2 plus 2 plus 2 plus 2, 5 times is going to be 10. So instead of using this rule, you're going to just say it's 2 times n. Summation to the I is going to be n plus I, n plus 1 over 2. Instead of using this one, you can use the rule. That means if you have from I equal 1 to the n, to the I, you're going to plug in 1, 2, 3, 4. And instead of doing this one and add the terms, you're going to say, okay, it's n plus 1 divided by 2. Summation to the I squared is going to be n plus 1, 2n plus 1 over 2. There's a proof for each one. You want to check it on the notes, on the slides. Summation to the I equal I to the n, I cubed. It's going to be n squared, n plus 1 squared divided by 4. Again, there is a proof for each one. But we're just going to use the formula. If you want to see the proof, go ahead and check the slides. Summation from KAI. If there's a number, you're going to take the number out. So it's going to be K summation from I equal 1 to the n AI. Summation, if you have 2 terms, you're just going to distribute the summation for the first one plus or minus summation to the second one. So this is the summation formulas. We're going to use these formulas a lot in this section. So we're going to find, they ask you find summation k plus 2. And k started from 3 to 6. K started from 3 to 6. In this case, we need to find the sum for these numbers. So what are we going to do? We're going to plug in k 3, 3. So this one is going to be equal, starting from the first number, that's meaning 3 over 3 plus 2. Plus the first term. Then the second number is going to be 4. So it's going to be 4 over 4 plus 2. Plus the third number is going to be 5. That means 5 over 5 plus 2. The last number is going to be 6. That means 6 over 6 plus 2. So now it's going to be equal 3 over 5 plus 4 over 6 plus 5 over 7 plus 6 over 8. Tell me how much it's going to be. And be careful when they ask you. They ask you to write down as a number the fraction. About 400 something, 120, I think. So do not write down decimals. They ask you to write down as a fraction. Or just write down as a fraction. The second one, we need to use the sigma notation. So that's really important. That means I need to write down this term. I have this side, I need to write down the sigma, which is the sigma is means summation from which term to which one. So the first thing, this one is going to be equal from I equal to n. Now I need to write down this term. I'm gonna look to the first number, the first term here. The top part is always 3. The top part is always 3. So I'm gonna write down 3 here. Okay? The bottom part, the second number is always 2. That means this one is going to be plus 2. Okay? Now start, check the first number. 1, 2, 3, keep going until 11. That means I start, this one is going to be, you're gonna put I, and I start from 1 to 11. So it's going to be summation from I equal 1 to 11, 3, I plus 2. This is I. So when I equal 1 is going to be 3, 1 plus 2, the first one. When I equal 2 is going to be 3 over 2 plus 2. When I equal 3, from 3, 3 plus 2, and keep going. When I 11 is going to be 3 over 11 plus 2. So that's the result. The same thing for this one. 1 over 7 times 1, 1 over 7 times 2, 1 over 7 times 15. So we're going to do its summation from I equal, check the first number is the same thing. So 1 over 7. And 1, 2, 3, 4, 5, 6 until 15. So I'm going to put it 7i. And I equal from 1 to 15. That's it. So the whole thing here is equal. Summation from I equal 1 to 15, 1 over 7i. So let's check this one. Find the sum of from k equal 4 to 8. 1 over k squared plus 4 is going to be equal 1 over k squared, that means 4 squared plus 4, plus 1 over 5, so it's going to be 5 squared plus 4, plus 1 over 6 squared plus 4, plus 1 over 7 squared plus 4, and until 8. So plus 1 over 8 squared plus 4. And then it's going to be 1 over 16 plus 4 plus 1 over 25 plus 4. So 1 over 29 plus 1 over 36 plus 4, 1 over 40, 1 over 49 plus 4. So 1 over 53 plus 1/64 plus 4 1/60. You're gonna add these, going to be approximate to this number. 0.430. They're not gonna tell you. And they're gonna tell you how many decimals. Next example, use the sigma notation to write the sum. Let's check. We're gonna do exactly the same thing. So this one is going to be equal. Here's the summation. From which number? Always check which number is fixed. Summation from 8 on the top. Here's the 8. And from I equal to which number? 2, 2. So the first number here is fixed. So it's going to be 2 plus. And the second number is 1. This one's supposed to be 2. So it's going to be 2 plus I. 2 plus I, and I start from 1 to 11. Let's go to the next one. Summation from I equal 1 to 24, 6. Remember, there is one of the summation formulas, which number is number 5. If we have K, if we have summation Ki, you're going to take the K out. So it will be K summation to the I. That's what I'm going to do here. So this one is going to be equal 6 summation from I equal 1 to the 24 to the I. Now, next step, I'm going to look to this part. I'm going to keep the 6. Keep the 6 summation to the I. Remember, there is which one? Number 2. Number 2 is summation from I equal 1 to the n to the I is equal n plus 1 divided by 2. So I'm going to use this one instead of this one, this part. But instead of n, it's going to be 24. That means this one is going to be 6 times n and n plus 1 over 2. But instead of n, you're going to put 24. So it's going to be 24 plus 1 divided by 2. Simplify the 24. This one with this 24 divided by 2 is going to be 12. So it's going to be 6 times 12 times 24 plus 1, 25. So how much is going to be the big number? 1,800. That means if you add the numbers from I equal 1 to 24, but multiply by 6, the result is going to be 1,800. Okay. Let's see, because that's the way you have to think about. There is no rule that says if you have multiplication, you're gonna say, okay, it's summation to the I times summation to the I plus 4 square. There's no rule that says that. This is wrong. Only if you have add or minus. So what I'm gonna do, I'm gonna say, okay, can I simplify this term? I plus 4 square is going to be, the first one is going to be, let's look like I plus 4, I plus 4, okay? That's mean I times I is going to be I square, plus 4I, plus 4I, plus 16. Combine the like terms, so it's going to be I square, plus 8I, plus 16. Okay, so what I'm gonna write down here, it's the same thing equal summation from I equal 1 to 6, I, and this one is going to be I squared plus 8I plus 16. Now, what's the next step? Can I distribute the I here? So that's what I'm going to do. This one is equal summation from I equal 1 to 6. I times I is going to be I cubed plus 8 I squared plus 16I. Now, can I say it's summation I cubed plus summation 8? Because it's a plus now. So this one is going to be equal summation from I equal 1 to 6 to the I cubed. And I have rule for this one. Plus summation from I equal 1 to 6, 8 I squared. Plus summation from I equal 1 to 6, 16I. Now, can I take the 8 outside the summation? Can I take the 16 outside the summation? Yes, by using rule number 5. So this one is going to be summation from I equal 1 to 6 I cubed plus 8 summation from I equal 1 to 6 to the I squared plus 16 summation from I equal 1 to 6 to the I. Now it's easier. And we're just going to use the rule. We're going to keep the first one, I cubed, which is rule number 4. So it's going to be n squared n plus 1 squared divided by 2, divided by 4. This is the rule number, which number 4. The second one is going to be 8. And on the top is going to be rule number n plus 1, n plus 1, 2n plus 1 divided by 2, rule divided by 6, rule number 3. And a plus, you can use rule number 2, which is for the I. So write down the 16. It's going to be n plus 1 over 2. Now it's just you have n and numbers. We have to simplify. Well, this one is going to be equal. This is 6 squared. 6 plus 1 squared divided by 4 plus 8. Here is 6. 6 plus 1. 2 times 6 plus 1 divided by 6. The plus 16. 6 plus 1 divided by 2. Next step, which is going to simplify. Here is 6 divided by 4, right? And this is 7 squared, 8, 7, 12 plus 1. So tell me how much is going to be. All numbers going to be also a big number. I have to graph G of x. So find the width, which is the interval is going to be always, this is the A, and here's the B. So it's going to be 2 minus 0 divided by 5, because we're going to divide our graph to 5 rectangles. So that's why we're going to divide by 5. That means the rectangle we're going to get here, the width, start from the 0 And how much you're gonna add? You're gonna add 0.4. That means it's going to be 0 plus 0.4, 0.4. Then let's do it here, 0.4. You're gonna add 0.4, gonna be 0.8. 0.8. You're gonna add 0.4, going to be 1.2. You're gonna add 0.4, it's going to be 1.6. And let's do the 2 here. There's our rectangles. But before I'm going on, I need to find the graph of g of x. So I'm going to use these points to graph g of x, which is 0, 0.4, 0.8, 1.2, which is the rectangle, but I need to graph my function, which is negative x squared plus 5. So we're gonna plug in these points in our g of x. So the first one, we're gonna get 5, 4.84, 3.36, 3.56, and 2.44, and 1. You're gonna put these points on the graph. Let's just do approximation. So for the first one is going to be, for the 0 is going to be 5. For the second one is going to be 4.84. I'm gonna say here is 4.84. This is 4.84. The second one, that's means here. And 0.8 is going to be 4.36. So let's say here 4.36. 4.36. So it's going to be here. For the next one is going to be 3.56. That means it's going to be here. Let's say here's 3.56. So my point is going to be here. And for the next one, 2.44. So here is the 2.44 here. The last one for the 2 is going to be 1. So here is the 2, is going to be here. That means our graph is going to be like this. I just need to grab until here. I'm not going to care about that because that's my area. I'm going to find between 0 and 2. So let's divide these, write down the angles. We're going to start from they ask you to use the left and right endpoint. The left and the right. So the first rectangle is going to be until 5. We're going to go like this. And here's our first rectangle from the left. 5, and going to the next point, which is 0.4. The next rectangle, the second one, is going to be start from this point because it's from the right. This is the second one. The third one, we're gonna start from this point, go down, and the third one, start from this point, going down, and the last one, start from this point, going down until 2. That's me. The left one, the left endpoint. Careful, the left endpoint. So now, the length here on this rectangle, the length here is 5, or the length here is 5. The width is 0.4. So the length here is 5, the width is 0.4. That's mean 5 times 0.4 plus the length on the second rectangle, which is this point. Here is the length for the second rectangle, which is 4.84. That means it's going to be 4.84 times the width, which is 0.4. You see the same width for each rectangle. The length for the third rectangle, which is going to be 4.36, and the width is also 0.4. So it's going to be plus 4.36 times 0.4. I keep going. The length for the next rectangle is going to be 3.56. Let's see it plus 3.56 also times 0.4. So we have 1, 2, 3, 4. The length for the last rectangle is going to be here 2.44 times. So let's see, it's a plus 2.44 times 0.4. How much is going to be? It's only for the left. Again, this method is approximation. 8.08. So 8.08. This is just the left end point. See, that's the last rectangle. Now we're gonna do the right one. The right rectangle is going to be start. Here's this point. You're gonna go like this. So here's one. Now here's our first rectangle. Now, with the second point, here is the second rectangle. This is the second rectangle. Then you're gonna go to the next point. This is the third rectangle. You're gonna go to the next point. This is the fourth rectangle. And now this is the fifth rectangle. That's why we have error, because you see, we have extra space here with the first part when we did the left end points, and we have extra space here when we did the right end points. We're going to lose this part because we need to find the area for this rectangle, and the area is going to be between the left and the right. So now the right end point is going to be, we're going to start from the right. That means it's going to be the length on this rectangle is 1. So 1 times 0.4. 1 times 0.4 plus the second rectangle. The length for the second rectangle is going to be 2.44 times 0.4. So 2.44 times 0.4. The length for the third rectangle, which is this one, is going to be 3.56 times 0.4. Here's the third one. For the fourth rectangle, is going to be 3.36 times 0.4, and for the fifth one is going to be this one, 4.84 times 0.4. Tell me how much going to be.
Got 6.2.
6.48. Okay. if you see now 6.48 and 8 point, that's mean our area is between 8.08 and 6.048. So the area, the approximation area, is going to be between these two, the left end points and the right end points. I mentioned this definition, and that's what you're going to use the first lecture on culture. Division of the area of the region in the plane, let F be a continuous and non-negative on the interval AB. The area of the region bounded by the graph of F with the x-axis and the vertical line, because you're going to find a certain region. Like, here's the graph. I need to find until here from 0 to B. So until this vertical line, that's what I need to find. The area between the graph of F and here's the x-axis and the vertical line x equal B. That's going to be the exact area. Why? Because the area, we're going to take the limit. As n approach to the infinity, the summation of F to the CI, this is the distance 0.4. This is the distance, okay, between 2 points, between two rectangles is going to be, delta x is going to be B minus A divided by N, and CI between the 2 points you're going to find on the x coordinate. So that's mean you're going to, here's the graph. Every time when you maximize the number of rectangles, because you're going to maximize the number of, instead of finding 5 rectangles, you're going to do 100 rectangles, but the distance is going to be super small, like, because you're going to say, okay, B minus A divided by 100. That's mean you're going to get a lot of rectangles, 100 rectangles. Every time you keep maximizing the number of rectangles, you're going to approach to the exact area between the x and the curve, okay, on the function f. So that's why we're going to take the limit and the sum on the same time. We're going to do an example about that, but we're going to find the limit. And again, you're going to go back and use the summation rule, summation formulas. So let's check this example. Okay, you say, okay, I'm going to solve this one because we know how to use the summation. We know we already studied the limits, so I'm going to keep the limits the last step. Now let's check this one. This is equal. Here is our limit from n to infinity. I'm not going to do anything with this one. Now let's look at some multiplication. If I look to this term here, it's a 3 divided by n. N is the last term, right? That means it's a number. So can I take this one outside the summation? Because it's like a number, so we can take it outside the summation. That means I can say, okay, it's a 3 over n summation from I equal 1 to n. I'm going to keep this one as a 3 plus I over n. Now, what's the next step? Now I have addition between two terms. Can I say it's the summation for this number, a plus summation for the second one? That's mean it's equal the limit. Well, I always write down n to the infinity, 3 over n. Now I'm going to say, okay, it's summation from I equal 1 to n to the 3 plus summation of from I equal 1 to n I over n. Now let's check. What's the next step? I'm not going to do anything here. I'm not going to do anything here. What about this one? 1 over n. 1 over n is a number. Can I take it outside the summation? You see, I have to use the formulas. So I need to do the math in a way I can use the formula. So if I took 1 over n outside the summation, the left on this side is going to be summation I. I have a formula, it's the summation I. That mean is going to be limit from n approach to the infinity, 3 over n. I'm going to write down now summation I equal 1 to n, 3 plus 1 over n. And I can say, okay, it's summation from I equal 1 to n just to the I. Okay, now this is, I can use the whole here, I can use the whole here. This one is going to be a limit from n approach to the infinity. We have 3 over n. Let's see what's left here. Summation to the 3 is going to be the number times n. That's mean 3n. Plus 1 over n. Summation to the I is going to be n plus 1. n plus 1 divided by 2. Now, can I simplify it? Limit the n approach to the infinity. I'm going to distribute right away. So 3 over n times 3n going to be 9n over n plus 3 over 2n squared. And here is n and a plus 1. Yes or no? 3 over n times 3n is going to be 9n over n. Plus 3 times 1 is going to be 3. And here is the n and a plus 1. And n times n is going to be n squared. And here is the 2. Next step, we can simplify. Cancel these. Cancel 1n with 1n here. So what's the left? It's limit. And approach the infinity. It's going to be 9 plus 3n plus 1 divided by 2n. And what's the next step? Don't look to the limit. What's the next step? Yes, how are we going to combine? We have to get the least common denominator, which is multiply. This is over 1. We're going to multiply by 2n. We're going to multiply by 2n. That's mean this one is going to be the limit. So n approach is infinity. It's going to be 18n over 2n plus 3n plus 1, inside down this, and use 3n plus 1 divided by 2n. Now I can combine these together. So it's going to be limit when f approach to the infinity, going to be 18n plus, distribute this one, 3n plus 3 divided by 2. Limit and approach to the infinity. 21 n plus 3 divided by 2n. What's the next step? Now we need to find the limit. How are we going to find the limit? We're going to divide everything by the highest exponent on the bottom. which is n. So I'm going to divide everything by n. That means it's going to be the limit when n approaches to the infinity, going to be 21n divided by n plus 3 divided by n over 2n divided by n. Cancel these. This is approach to where? No, 3 over n. When n approaches to infinity, this is going to be, don't forget that, like the fraction, always 1 over n. If n going to the infinity, 1 over n going to where? To the 0. That's meaning 3 over n going where? To 0. Because if I take in the limit for this number is going to be, well, this one is going to be limit when n approaches to the infinity to the 21 plus limit when n approaches to the infinity to 3 over n over limit to n approaches to the infinity to the 2. So the limit when n approaches to the 0 to the infinity, this one is going to be equal to 0. The limit for the constant is going to be constant. It means 21 over 2. Okay? So we're always not doing this one, but from this one, this is always 0. That means the left here is 21 over 2. The limit 21 over 2. Okay?